Hey guys, it's BlockchainBrad, and today I'm very honoured to speak with none other than Sam Williams. Sam is the co-founder and CEO of a very exciting startup or project, or more importantly, a very exciting business, and that is called Arweave. Sam, thank you very much for your time today.
Thanks for having me.
No worries, mate. I'm very excited about hearing about your very exciting project. I know that you were in Consensus recently in New York. A lot of buzz happening about your project. So you refer to yourselves as a new data storage blockchain protocol that is arguing that you can do quite a few things. One of them is that you say that you are truly permanent data storage for the first time, and also that you're trying to be permanent, low cost, and truly censorship free. So without further ado, Sam, obviously, we want to know about Arweave, but we also want to know about you as well. Tell us a bit about yourself. You are the CEO. Clearly, you have experience. You have a PhD. Tell us a bit about why you should be in the seat of CEO.
Actually, I don't have a PhD. I got
you're a candidate. Sorry, you're not far off.
That's right. Yeah.
Right. My apologies. I did read that.
No problem. I got 3 months away from graduating my PhD class. And then I decided to start Arweave with this sort of naive impression that I'd get 1 day a week to write up my thesis, which obviously didn't happen.
Right.
Yeah.
But I mean, in that instance, obviously there are many, very skilled people who don't complete their PhDs. It doesn't mean they're not in a position where they don't have the skill set.
Oh, I mean, for sure. Well, I would say that, right? But I'd written the operating system. That was the focus of my PhD work. It was just a case of writing it up that I didn't really get time to do.
Right. So obviously you have done you've been a candidate for the PhD. My understanding is that it is in decentralized systems or distributed technology. So can you tell us a bit about your knowledge about the studies you have done, and more importantly, the experience you've had in the tech field?
Sure. So the PhD was about a distributed operating system. Well, it was actually a distributed operating system inside a single computer. It built on what was called multi-kernel work, which was this kind of strange and interesting idea that came around in about 2009, where everyone thought that we would have 500 core computers within a decade, which obviously didn't pan out. But one of the interesting things that this multi-kernel work made possible was to treat a single computer as if it was a network of interlinked single-threaded computers. And so each of the cores on the processor would be treated individually, and it would have a specified segment of RAM each. And essentially, you could have it so that each of those cores could fail individually. But they would still continue to work together. So my work was on making it so that you could essentially survive some of the failure of the hardware inside the computer by splitting responsibility for the hardware across different cores.
I see.
So it was basically...
Well, there's quite a lot of work being done in operating systems, even in the decentralized field right now, and I'm sure you'd know of some of them. And many of them did actually start with that kernel research right the way through back to centralized systems with Microsoft. So it's not surprising that you've led down the track of blockchain, seeing the value points that it has. But let's now talk about the actual project that you started. Obviously, it's pretty recent. You've done it for approximately a year. Is that right?
Yeah, that's right.
Okay, but there are serious innovations in what you're trying to do. So let's unpack that from the beginning in terms of what you are and why you are innovative, even in the sort of the area of blockchain, or more importantly, in DLT, in the decentralized and distributed ledger technology.
Yeah, for sure. So Arweave uses a number of novel technologies, the first of which is the Blockweave.
Right.
The Blockweave is essentially like a blockchain, but instead of just including the hash of the previous block in the generation of the next block, you also include the whole contents of a randomly chosen previous block from the network in the production of that next block. And what this does is it forces a system that we call proof of access, which is that miners in the network have to have access to that old block and can't predict which block that will be ahead of time. And so essentially the best strategy for them to employ is to store as many of those old blocks as they can in order to be able to take part in the generation of as many new blocks as they can.
Right. So obviously, just some key points there. Your randomization aspect, what you're trying to do also is essentially allow for different parts of your blockchain, parts of that storage to be valuable for the miner, not the entire data set, not the whole blockchain itself. Is that correct? As they try to utilize the blockchain, as they mine, they don't have to use the full node?
That's correct. Yeah, they don't have to be a full node.
Right.
But the financial incentives are set up as such so that it's in their best interest to store as much as they can.
Right. Well, let's explore this a little bit more, perhaps for the lay person. Let's go back to the problems that precipitated why you created Arweave. Obviously, there are key ones with regard to centralized data and also the decentralized. Let's talk about that, and let's talk about what motivated you to really build out Arweave.
So what really motivated me to get started with Arweave was this idea of building a permanent record of human knowledge and experience in one place.
Right.
The idea being that we've reached a point with technology now that we can coordinate computers such that we can make many redundant copies of a piece of data. But what was really different about what blockchain opened up essentially is decentralized incentive networks, and using that as a means of enforcing the maintenance of a system like this. So what we did was we focused those decentralized incentive network effects onto the replication of data in the system. The idea being that then we could use that as a way of having this permanent record of human knowledge and history, really.
I see. And obviously that permanence is important because it replicates some of the more centralized models you've seen that have value, but are doing it in a different way. But let's now talk about Cambridge Analytica as an example and why that's relevant to what you're actually trying to do to counter that.
Yeah, well, I mean, there's data ownership problems, aren't there, with centralized systems. So certainly, well, we focus on the idea of individual personal responsibility for data replication and ownership.
Right.
Through essentially a system of, encryption. So you can store the information that you want to have access to later onto the Blockweave, and then you can remove the encryption key for that data, making it essentially worthless to anyone else, if you so choose.
I see, and that's really important because obviously making that worthless and making it really specific for that user removes the control, that degree of centralization that was relevant in that recent Facebook scandal that we saw, given that a lot of that wasn't known by the user, just how that data was being utilized from the inside out. But aside from that, obviously one of the things you are trying to do in the decentralized space is really move forward from the original iterations of even blockchain data itself, right from BTC. So could you talk us through that and how you've grown, you've evolved from that original iteration?
Yeah, so blockchains are great for replication of data and actually immutability and permanence. But the problem was that they couldn't scale to store large amounts of data. So what you get with something like Filecoin or SEER is that they have a decentralized storage network in the back end, and then they use a blockchain for settlements of payments, essentially. And they don't actually store the data on the blockchain. And what that means is you don't get the properties of a blockchain applied to that data. So what we've done is we've essentially made it so that the blockchain itself can scale to include vast amounts of data on-chain, so that you maintain all of those properties. And also, we've changed the proof of work mechanism so that it has a positive externality. This is probably one of the most interesting things that our project has managed to achieve. Is that the proof of work in the system that the miners are forced to take part in order to come to consensus actually does something useful, which in our case is replication of data.
Right, and obviously that usefulness is really key. It gives the purpose for the miners to apply the proof of access in a really practicable way. But let's explore now, I guess, the protocol itself, because you have essentially a protocol, and then you have what is a like blockchain, given that you have Arweave and you also have Blockweave. So can you tell us the difference between the two, so that people can understand, how the architecture really plays out?
So the Arweave is just an implementation of a Blockweave. A Blockweave is the kind of structure that you could apply to other projects. But obviously its first implementation is inside the Arweave.
Right.
Well, as the core of the Arweave, yeah.
Okay. So with regard to the Arweave itself, can you also explain some of the core elements? You do have 4, my understanding is, and you broached them recently, but they are so pivotal. So perhaps we could go into detail one by one about them, starting with perhaps the Blockweave itself. If you could tell us a little bit more about just how it works, what underpins it, and then we can move on to the proof of access and proof of work algorithm.
Yeah, so the Blockweave and the proof of access mechanisms can't really be decoupled.
Right.
One implies the other.
Sure. So
the Blockweave is this blockchain that's modified to include a previous block from the network in the production of the next block, as well as the last block. Mm-hmm. And so it creates this kind of weaving structure. It's almost pretty basic from that point of view. In fact, I've actually pointed out in a couple of my talks before that this is really quite a simple modification, but the extent of the things that it gives you is pretty profound.
Right. So the implications for the applications and the users is really, really significant. And obviously that relates to the proof of access itself. That is something quite, innovative in itself. We've talked about the randomization aspect, but just why does the proof of access set everything apart?
Well, it's this. It's that it's got this positive externality. It's that it actually achieves something useful, which is what we call incentive engineering. So most of the time when you're writing these decentralized systems, it's not really about the code that you're putting onto into the file precisely. It's the things that manifest from that code in a decentralized environment that can actually be very different. So you do something like you add a randomly chosen previous block into the generation of the next block. Mm-hmm. And like in the code, that's actually very simple. But the effects that has on the incentives in the network, are very deep.
Sure. Well, in that respect, can you talk us through, let's say I'm the user and I'm a miner, can you talk us through the value point from the miner's perspective? Obviously, incentivization is a key asset to you. So let's talk about that in the process.
Yeah. So the miner, in order to mine the next block, has to have this recall block, we'll call it, right. This old block network. But because the miner can't predict ahead of time the recall block that will be required to mine the next block, their best strategy is to hold as many of the old blocks as they can. And this is reinforced by the fact that essentially the more data that is stored in the system, the less hashing happens, broadly. Right. And from the point of view of the miner, the hashing is very expensive. So if they're thinking about optimizing their mining setup, the thing that they need to focus on first is optimizing the amount of the old data in the system that they have available, rather than the hashing power. So like if I have 10% of the Blockweave available, and I have a $3 million hashing farm, say, mm-hmm. then the incentive for me to increase that amount of the data that I'm mirroring from 10% to 100%, rather than increasing, say, the utility of the mining farm, the hashing part of the mining farm, by 10%, mm-hmm. Is extreme. You're always forced to optimize for that storage first. Right. And in doing so, you essentially make a system where the miners are incentivized to do something that is useful to the user in the long run, right. Which is storage of this old data. And what's really cool about it is that because you're essentially offsetting value that the miner would have to expend elsewhere, we can actually make that data storage fairly cheap.
Right. Well, obviously, in comparison to BTC, I mean, I've heard you mention this in other interviews, there's a significant difference just in terms of even the gigabyte versus the byte. So you could tell us a bit about that in that comparison. And also, could we talk about the scarcity in terms of as the scarcity of the actual transaction becomes prevalent, there's a much greater value point for the miner. And you've even alluded to timeouts happening, whereby that becomes quite an attractive feature of your design, because again, it builds the value of the block itself, of the recall block.
Yeah, okay. So I think what you're referring to is essentially, if we have a block that almost nobody is mirroring, then if that block is chosen as the recall block, the pool of miners that are competing in the hashing competition, which sort of happens after you verify that you have the block available,
Right.
is extremely small. So there might be, say, a 1 in 4 chance that you get the block. And what this means is the rarer the block, the higher the incentive for you to mirror it,
Right.
which necessarily means that it averages out in the end, because the miners are incentivized to pick up those blocks that are rare.
Sure. And that's obviously a good incentive for miners themselves, no doubt. Well, Sam, obviously there's a lot to your project, and we've discussed now 2 of those core elements, but you also have Wildfire and Block Shadows. They are really significant in what they do. So can you tell us a bit about Wildfire first?
Yeah, so back when we first started the project, we, well, actually, originally it was just planning to be a permanent internet archive on a blockchain, would you believe it? Which was obviously not a very appropriate thing to be doing.
Right.
That's why we were sort of forced into this building of the Blockweave. Mm-hmm. And so that was good. And now we have scalable data storage on a blockchain. But it's all well and good having data storage. Right. But if you can't have data recall, then, it doesn't quite work. So what we did was we built a system of incentivized recall of data, which we call Wildfire, which can be summarized essentially as, if you share data with me, I will share data with you. And if you share data with me quickly, I will share data with you quickly. So from the miner's point of view, it's very important that they get access to the latest block in the system and all of the associated transactions in a timely manner. In order to mine efficiently, this is critical.
Okay.
So essentially, each of the nodes individually is they rank their peers based on how quickly those peers respond to requests for data, and they distribute new data to their peers based on that priority queue.
I see.
And in doing so, what they're doing is incentivizing each other to be quick in the delivery of data. And what's really cool about this is that it actually incentivizes, no, it doesn't quite incentivize. It leads to a network topology which prefers near nodes geographically. Or it's not even geographically, it's based on the underlying substrate of the internet infrastructure. So if you're in Beijing and I'm in Tokyo, and someone else is, let's say Alice, is in London, then you can transfer data to me very quickly, but you have to spend a lot more time transferring data to Alice. And so I'm going to prioritize you for the distribution of new data, whereas Alice might put you nearer the bottom of the list. And what this means is that the architecture, the topology of the network naturally molds itself to fit on top of the underlying internet infrastructure on which it's running. And essentially doing this means that we build, a map of the internet infrastructure, and we distribute it quickly across it.
So it's almost like, in a sense, layering on top of the TCP/IP model, in that it's connecting with more proximate information, more proximate nodes, more proximate, essentially, blocks as it builds out. Yeah,
it's all about proximity.
Okay.
And this essentially builds a system that that its namesake comes from. The idea that the blocks, the new information in the data in the network spreads like wildfire, right? Because it goes from these nodes that are very close together, sort of pinging out across the world very quickly.
I see. So it's a domino effect in a sense, Sam. And in that respect, is this some sort of innovation that you've come up with?
Yeah, we think so. It's the incentivization of data sharing that's the really important part. The fact that it's fast is actually just a sort of nice byproduct. But really the key thing is that you've got to be able to incentivize miners to give each other data.
Sure, and obviously this is something I wanted to ask you later, but it's a perfect segue. So clearly your vision with respect to even the World Wide Web, this is a perfect coupling of that. Do you foresee that this is some sort of data storage facility that can really benefit something like the decentralized web?
Yeah, for sure. The end game of what it is they're attempting to build is a decentralized permanent internet.
Right.
And that's why we started with the system being accessible through your browser. So any resource you can find in the Blockweave can be accessed just by pointing your browser to the right place, and it'll load up just like a normal web page would.
Right. So clearly it's not just simply about some sort of fantastical idea. You really genuinely want to be in the use case space where you can be used by millions of people around the world in a very practical and seamless way without them even knowing perhaps that this is the technology that underpins it.
Yeah, for sure.
Right.
We want to incentivize people to download the web extension and get started using it themselves. And so if they go to an arweave.org/tx/ whatever the TX ID address is, it put a little box at the top that says, hey, you're viewing this through a centralized mechanism, but if you download our web extension, you can view it through a decentralized mechanism. And then it tells people a bit about the project.
Sure. And what's exciting also, Sam, about what you're doing is you are genuinely incentivizing developers. And we'll discuss that later, but there's a really exciting program or process that you've employed to really build this out. But if we could now talk about block shadows, because that, again, is your fourth element and is really important in terms of how you're trying to fast track. You obviously have very high transaction throughput. So, how fast are you actually, and what's the role of scalability in your design?
Yeah, so the theoretical limit to the algorithm we're using, the block shadow system, is 5,000 TPS on a 100 megabit network. And again, we have to go back to Wildfire to see that actually we're incentivizing high throughput networks to start with.
Right.
So 100 megabit is fairly optimistic for a normal commercial network. But because of the way that Wildfire works, it's actually incentivizing people. Miners are rewarded for the quality of the network connection that they're bringing to bear. So at a base level, we start with better network connectivity than other decentralized networks.
So comparatively, I mean, we're talking about very high speeds now, Sam. Do you envision that you will even become faster? As not that that's necessarily the premise, but clearly you're already very fast.
Yeah, I mean, it's all based on the quality of the network connections on average in the system. So as those improve, which they naturally will do over the next 10 years, 20 years,
sure.
So too will the maximum TPS that we can reach.
I see. Well, obviously, those elements are really key, and it's great to hear that you do have quite an outstanding, through your design with block shadows, that you do have such incredible scalability. But once again, it's not about trying to inject hype into this system. You clearly want to be here for the long haul, and therefore building out your tech to have real use case and utility. And to do that, you've also built out, my understanding is, block hash and even your wallet list as two key elements of your design as well. So what are they and why are they important?
Yeah, so the block hash list and the wallet lists are sort of necessary components to make the Blockweave work. Because the idea of a Blockweave is that you don't have to store all of the data, and you are rewarded proportionately for the data that you do store. So we need to make it so that people can join the network just loading the last block. And in order to do this, you obviously have to encapsulate all of the state in the system into this block. And so what we've done is essentially have a list of wallets, their addresses, their balances, and the last transaction applied to that wallet. And we've embedded that in the block, as well as a block hash list, which is the hash of all the previous blocks in the system. So that when someone provides you with a recall block, when they've mined a new block, you can verify that the recall block that they've given you is the correct one. But obviously this would mean that the size of the blocks would become bloated, right? Right. Which is one of the reasons that we came up with the block shadow system. And what I think is perhaps interesting about the whole project is we set out to build this permanent archive, and in order to achieve that, we've had to come up with all of these different algorithms, from Wildfire to block shadows, even the Blockweave itself, to actually make that possible.
So by default, you've created this entire system.
Yeah, we didn't intend to build a system that could do 5,000 TPS. It wasn't actually one of our main goals, even. Although it's a pretty side effect. The problem that we were trying to solve was that the blocks in the system have potentially unlimited size, and that obviously means that if they're distributed, there's a high potential that if you have a block that's, say, a gigabyte, and you try to distribute the entire thing to the network, that someone else is going to mine a block in the meantime, and then you're going to have some kind of competition about forks, and it becomes a nightmare. and it sort of clogs the network. So we had to come up with a way that you could come to consensus about very large amounts of information, in a timely manner. Mm-hmm. And what we came up with was block shadows, which is essentially a system that says, okay, when you receive a transaction, instead of verifying it, forwarding it to your friends, and then immediately starting to mine it into a block, and then when you mine the block, distributing that whole block, including those transactions again to everyone else in the network. Mm-hmm. Why don't you, when you get a transaction, you verify it, you send it to your friends, and then using the wildfire system of prioritization, and then you wait for a period of time until you're highly certain that everyone.
It looks like we've frozen for a moment. Sorry about this, Sam. I think we've frozen. So block shadow. We're finishing off on that bit.
Yes. Right. So what we do with the block shadow system is when you receive a transaction, mm-hmm. you verify it, you send it to your friends in preference order dictated by the wildfire system. And then what you do is you wait until you have an extremely high confidence level that everyone else, or almost everyone else in the network, has received the transaction in question before starting to mine it into a block. Right. And what this means is that then when you do mine a block, instead of having to distribute that whole block to everyone, you can just say, okay, here's the hash that you should get, here's the nonce you should use, and here's the order of transactions that have to go into this block in order to essentially rebuild it. So what you're doing is really just sending them a kind of instruction set, mm-hmm. and then mm-hmm. from their local cache of stored transactions, they can rebuild it. And so that means that you can come to consensus, essentially CPU processing speed rather than network distribution speed.
I see.
And
so it's almost like a It's almost like a snapshot as well of the overall. It's almost like a blueprint that optimizes everything because you're not utilizing the whole chain to do it.
Yeah, precisely. It's a blueprint for rebuilding the block in question rather than the whole block itself. Mm-hmm.
Well, that's exciting because obviously that's once again that's another degree of innovation that you've built into your architecture, and clearly there's allusions to other perhaps consensus algorithms that are out there, and I did want to broach that with you for a moment because your proof of access is quite similar in many respects to proof of space in that consensus. So I don't know if you're familiar with that, but are you in fact, and can you comment on that?
So proof of space typically is just some kind of, for example, how Burstcoin does it. Right. They have a system where you plant a seed across a number of fields, mm-hmm. and then you show that you have access to a certain amount of hard drive space by randomly accessing that data. But critically, the data stored there is random. It's literally, it's random data. It's worthless. The key innovation that we have is that the data that you're using in the consensus mechanism is actually useful to other people.
I see. So essentially, it's much like converting that proof of space into some sort of usable context, as you mentioned, with a usable proof of access. And once again, that scarcity, if we could talk about that just for a moment, to really just reiterate that value for the miner itself, because what is really interesting about what you're doing is that you're incentivizing by creating scarcity, by creating value for the block itself.
Yeah. So essentially, rare blocks are more valuable because if they're chosen as a recall block, you are competing against fewer people in the generation of the next block, which means obviously that you have a higher likelihood of gaining a reward. Right. And if it becomes, in the extreme case that no one can find the recall block, well then the transactions in the system, they sort of back up, which means that the reward available to the miner that does eventually find that block becomes higher and higher. And so, this incentivizes people that maybe disconnected their mining machines to look back on their hard drives and say, okay, do I have that block in question? Because if I do, and I'm the first person to get it to the network, then I have like a 100% chance of receiving a very large reward.
I see.
And so what this does is it creates a selfish incentive for the miners to provide a really useful service to the network. And once that block is mined, once that new block is mined, the recall block has to be redistributed to everyone. And in doing so, you've sort of respread the data across the network, allowing everyone to make a new mirror of it, and so making the rare block not so rare anymore.
I see. So once again, you've really built in that incentivization model very, very clearly for the miner. But in the instance, let's say, where the chain itself slows or even stops and comes to a halt for a moment, is that an issue for you, or is that in fact something that is something you view positively for the overall, once again, that incentive structure?
Yeah, so it is part of the incentive structure that this happens. We've got some thoughts about potential upgrades we might make to the network in the future that have optional recall blocks. So you could say you either have to have recall block A or recall block B. And if nobody picks up recall block B in a certain amount of time, then it's dropped from the system. And so essentially you can have... you can make it so that the network doesn't stall at any point.
Right.
But the point of the network, this isn't supposed to, although it can do this with the block shadow system, this isn't supposed to be a massively high throughput blockchain appliance. The point of it is to provide long-term storage of data. So it's more important for us to prioritize that data is found and redistributed around the system than it is that it doesn't pause for a short period of time.
Right, obviously that, once again, you've thought about that. Now, what about in terms of compliance? I noticed that you have a compliance archive built in and you have a voting system as well. Given that compliance is so imperative right now, can you talk us through that as, once again, another innovation you've built in? Yeah,
so we want the system... we got into building this whole thing because we wanted to ensure that the idea of the Orwellian memory hole could be removed. This idea that an authoritarian state could remove records of the past or even modify them to suit their ends in the present and thus control what happens in the future.
Right.
And then so obviously avoiding censorship of the content on the system is extremely important to us. We're also, aware of
top-down enterprise and government.
Yeah, you have to have some kind of content policy in the system.
Sure.
At a basic level, because you can't force miners to do something they don't want to do. There's a really basic element to it that you can't get under that. And so what we've done is we've created a system that we call decentralized content control or decentralized content policy, depending on which way you look at it. And what it does is it allows miners to employ a blacklist of content that they won't allow into a block. And basically, these blacklists enable the miners to kind of vote. So if more than 51% of the network doesn't allow a certain kind of content into the block, then it won't be accepted. And what's interesting is that actually other miners are incentivized not to attempt to mine transactions that they believe the majority of the rest of the network won't accept either.
I see.
So there's a sort of downward pressure in that regard. But also there's an upward pressure too, which is that the majority of the miners' rewards come from transaction fees. And so they're incentivized to act in a sort of reasonable manner. They don't want to accept too much content that they think other people in the network won't accept, but they also want to accept enough transactions that they make a reasonable profit.
I see.
And
so it fosters diplomacy in a sense and consensus.
Yeah, precisely. The idea is that it fosters reasonable actions in the system in a democratic way. There's no top-down censorship of any kind. It's just the miners choosing amongst themselves what they think should or should not be accepted into the network.
Right. And just talking about the verifications you were mentioning before, you've built in an ongoing verification system as well through the whole Arweave network. So how important is that in terms of, being arguably a robust verification system?
Verification in which, there are lots of different...
Sure. Well, my understanding is that in your light paper, one of the key features that you'd built out was you'd built out an ongoing verification system, namely that it built out so that not only once do you verify, but it continues on through the process. Are you familiar with that term?
Yeah, so essentially with the Blockweave, because you're looping in these old blocks and everyone has the hash of those blocks because of the block hash list, yeah, you constantly re-verify the data in the system over and over again, naturally as it progresses forwards. And again, there's a financial incentive for the miners to do this. I think like it's kind of like an iceberg, right?
Right.
The actual algorithms as written in the code that we've created maybe only accounts for 20% of all of the things we've actually built.
Right.
The 80% is the incentive structure that's built underneath the network.
I see. So that's obviously really fundamental, and we'll learn more of that as it comes to the fore, as you become more of a use case in the space. But let's now talk about your applications as well, Sam, because you have built some pretty interesting things, and you've made an interesting comment, a very interesting comment about decentralized Facebook and decentralized Twitter. So clearly these are some of the potentials of your design. Let's talk about them in terms of use case, applications, and what you plan for the future.
Yeah, absolutely. So back when Ethereum was going through its pre-sale, I purchased some tokens because I wanted to make sure that I could build some applications on this decentralized computer. I thought that was a really great idea.
Right.
But unfortunately, it's just not practical or viable to build. Realistically, most of the applications that developers actually want to produce on something like Ethereum at the moment. And the reason for that is they're decentralizing computation, which has some pretty fundamental limits to it. So either you have every machine in the network run every instruction in every program at every time step, or you have a system where only partially you verify the data transformations or computation in the system. Right. So that would be like a sidechain type affair where Alice and Bob are both trying to transact. So they talk to each other, they run the instructions in the system, and then if they agree on the output, then you put the response of that back onto the blockchain.
Right.
And if they disagree,
and we see that a lot happening because we have often these main chains or root chains and these side chains for concurrent scaling solutions. But you're different. You're built as one whole on-chain system.
Yeah, completely. So we think that while these sidechain systems are good for some use cases, they're more like guided computation. It's more like verified computation than really decentralized computation.
Right.
So other than making it so that you can run a program in the cloud, if you like, in some kind of ephemeral global computer, what you're doing is just making it so that Alice and Bob can agree on the computation that they've performed. That, is a far cry from the idea of building a decentralized web application.
Okay.
There's really almost nothing about it that's the same. So what we've decided to do was to take the approach of decentralizing storage, not computation. Because we noticed that for something like Facebook or Twitter, actually most of the computation that happens in the system can take place on the user's computer themselves, because they can only write data for their account onto the network. So there's no potential for bad acting against other people, because they can't modify things that other people own anyway. They can only write things associated with their private key or public key. So if you see that they're perhaps layered on top of user accounts, that means that Alice can write some tweets and put them onto the network, but she can't pretend to be Bob anyway. So there's no real need for trusted computation in a lot of these systems. What we've done is we've made a kind of decentralized application architecture where instead of using a database that's centralized or even potentially local to the user's machine, you use one global decentralized data storage mechanism, and then you write the application just as you would in any normal programming language, and you just simply replace calls to the database with calls to the Arweave. And yeah, in taking this approach, we've made it so that you can write real-world applications, if you like, in a decentralized manner.
I see.
So you either have web application servers sitting around the edge of the I just noticed my hand movements are out of shot. I tend to paint things with
no, that's much better, actually.
Oh, good. Excellent. So, yeah, you have like this decentralized database in the middle, and then you put web application servers around the edge, and then the users can access each of those servers. And because the data store is the same, the user experience they get from accessing any of those servers around the edges of the Blockweave is precisely the same. So you have the same real decentralization that you get in a system like Ethereum, but you can actually write the applications in whatever programming language you like, and they're fairly simple, and they run quickly, and they actually allow you to build useful things.
Right.
And then there's another potential architecture even where you don't have the web servers. What you do is you just serve a web page from the Arweave to the user, and then that web page itself allows the user to write information back to the Blockweave, and indeed to read it. And so you can have an entire decentralized, permanent, uncensorable Twitter-like system built entirely on the Arweave with no on-chain computation at all. It's just all on the user's computer, and interacting with the Arweave as appropriate.
It's fascinating because obviously you're really presenting an argument about storage as opposed to cloud, which we do hear a lot with arguably very leading blockchain projects right now around the world. Certainly we'd name a few, but we won't. But if we could now, if we could now also just really explore the magnitude or the benefits of being able to access these the multitude of programming languages. You do have the REST API facility built in as well. Just how important is it to be agnostic in that sense?
Well, I think for adoption, it's hugely important, you know. So again, like after a few years after I bought my Ethereum tokens, I was like, okay, how do I get going with this thing? And that process is extremely painful, I would say. Even as someone that, you know, in my spare time for fun, I build operating systems.
Is that because you can only use certain languages of Solidity in that instance?
Yeah. There's a pretty steep learning curve with these things, even for like an experienced programmer. So what we've done is we've made it so that even junior programmers can pick up building decentralized applications in half an afternoon, we think.
Well, that's exciting, Sam. That's really exciting because you're opening the door. It's open source by nature anyway. But could you tell us a bit about the incentivization system for developers? It's really interesting, and certainly it's tiered according to the degree in which someone wants to get involved.
Yeah, completely. So what we've done is, we noticed that a lot of projects, they have a kind of, they perform some kind of token sale, and then they want to incentivize people to use the system, so they create some kind of fund.
Right.
And we recently went through the Techstars Accelerator program, which is essentially a venture capital-backed 3-month course where they sort of teach you about how to run startups, and they introduce you to all the people that you might need to make your startup successful.
Right.
And one of the key things that we learned from that experience is actually picking good teams that are going to build excellent products is really, really hard. And it's a skill set that's pretty much disconnected entirely from the skill set of actually building a company.
Right.
So what we felt when we were putting together our incentivization system for developers was that it should be automated at a pretty basic level. It should be, okay, if you reach these certain milestones, then we'll provide you with an incentive of some kind, either R tokens by default, but also potentially at different levels, an ETH or fiat, investment into the company itself.
Right.
And so essentially what happens is we've created a funnel whereby if you start a GitHub repository or even a private one that you can show us some evidence of that says, okay, this is an application I'm going to build. It's going to do these and these and these things. Then you get a small number of R tokens. And then as you build out that application so that it actually puts its first transaction onto the chain, onto the Blockweave, you get another slightly larger number of R tokens. And then we start with a system that essentially follows seed, Series A, Series B, Series C funding models. Simply, the more data you push through the system, the higher the reward that you get as you progress along this. And what we like about this process is it's not up to us to choose who the winners might be.
Right.
It's simply a case of who is adopting the system, how fast are they doing it, and you get rewarded for that. So if you build an application that is successful, you will be rewarded, regardless of what we think about it or not. It's autonomous in that way.
It really is, and it fits the bill of decentralization in the sense that you're not vetting, you're not assessing as some sort of panel how the quality of this. And this could be a boon, it could also be something of a criticism, but certainly in the spirit of decentralization, you are fitting the bill because you're allowing all developers to access the tiered structure and really show their worth if they want to go ahead and build out something on your platform. So kudos to you, because it's something I have not heard of before, and certainly it really does provide anyone who wants to learn more about developing an access point to put their app on your platform. So
and we like it gives developers certainty as well.
Right.
It's not that they have to impress us in any way. It's just, if you gain adoption, we will reward you. Simple.
And it's interesting also because it's agendaless, in that, again, it removes even yourself respectfully from the equation, where you're not the assessor of this in any way. And clearly, we are seeing ironically, this happen in many instances around the world with hackathons happening. We see a lot of panels building out where, respectfully, that may be great, but you're doing something far removed from that. And obviously to do that, Sam, you need an excellent team. And I have had a look through. You do have other candidates with PhDs like yourself. Could you tell us about your team generally, not just the team itself, but your advisors as well, as more the latter discussion, as to why your skill sets are so diverse and why you've chosen this team and advisors to build out Arweave?
So Will, my co-founder, he's another academic. Well, I mean, if you can call us academics, we didn't finish our PhDs.
I think we can.
He was the sort of natural choice, I thought, for starting this project with. After I came down the mountain on which I came up with the idea,
right.
I reached out to Will, and then, we just got started with it. And he was working on a slightly different area of decentralized systems, which is actually neural networks.
Okay.
Which is interesting.
And so it's almost AI connected in that respect.
Very, very much so. But I think one of the things that's actually pretty fascinating about human psychology and maybe even existence is that human brains themselves are decentralized machines. They're built of neurons which work in parallel with one another.
Right.
In a totally non-top-down fashion. But maybe that's a different discussion.
But I think it's valid in the sense that essentially you were still looking for those who had that premise from the outset, looking for something that was decentralized and how you could build that with the skill sets that you have. So you have those PhD academic skills, but let's move forward now into wider areas of your team. You clearly have business in the forefront of your plan, but that seems to be more so in the advisory section. So let's explore that a little bit and why you've chosen these advisors you have.
Yeah, for sure. So there's Anthony, who came from Quantstamp, and he was the head of growth there, and he's been helping us out recently. I mean, actually, until very recently, we were flying quite under the crypto radar.
You were.
Very few people heard of us. But working with Anthony just the last couple of months or so, we've really arrived, you might say.
And you certainly, Sam, have quite a few advisors. Looking at different sectors of the business. Certainly you have a lot of people in your team who know not just blockchain, but know the cryptocurrency arena as well, and how sentiment markets are fundamental. They understand, no doubt, also key VCs. That you have an expert in that respect as well. So how important has it been to find these people and build out a holistic approach?
Yeah, exactly. Holistic is the word.
Right.
I mean, we've got people that cover all sorts of areas. So we're working with Jeremy Epstein on helping get the messaging, if you like, for the project right. One of the problems we've had is that our real long-term goal, 10-year aim, you might say, is to build this permanent decentralized store of human knowledge and experience. As a kind of parallel internet that is immutable, because we see that the internet is an ephemeral thing,
right?
So it's great for connecting people to one another, allowing them to communicate. In fact, it's really order of magnitude improvement on the ability for people to communicate with each other across geographic constraints. The problem is that it doesn't actually allow people to communicate with each other across temporal constraints very well.
Based on time.
Yeah, precisely. So if you write that blog post and then publish it on the internet, realistically, it's going to disappear at some point when either you stop paying for it or the platform that you're using stops paying for it.
I see.
But it strikes us that there are some kinds of things that you want to publish that aren't about ephemeral usage. It's not like a messenger. A messenger isn't the kind of thing, like an instant messenger.
Like Snapchat.
Yeah, you don't want to put that on the Arweave. There are things that you want to be ephemeral, but there are also things that you want to publish permanently.
Sure.
And we see ourselves as starting the sister network to the internet in order to do that allows people to do that.
Well, it's very exciting, Sam, that you are really trying to redress, in many ways, some of the inadequacies of the current web structure. And let's move now, to one of the more controversial topics for every CEO, and that is the token, the tokenomics, the token metrics. Clearly, you have a very, very low cap, to be honest. Can you talk us through why you did choose this low hard cap? Because I ask you this only that it tends to generate hype in this respect. So why that choice and why the tokenomics?
Yeah, I think realistically, most of the projects that are raising large amounts of money, they don't need the money that they're raising.
Sure.
You can deliver really good products on much, much less.
Sure. Especially something like $2 billion, which we've actually seen happen recently.
Yeah, it's completely crazy.
Yeah.
I hear some interesting rumors about that, but I'll talk to you afterwards.
Sure, absolutely. So going back to, you have an 8.7 mil hard cap, and and your total supply and that sort of thing. It's become, it's spread like wildfire. No pun intended, but it just has.
Yeah. So we're raising, as you said, 8.7 million. US, I think it is. We actually do it in GBP, so it always confuses me.
My apologies.
No, that's all right. I know the rest of the industry
right.
Works in USD. In fact, in retrospect, we would have used USD, but once we got started, it's just safer to stick with one. Otherwise, you confuse people.
Absolutely.
So we're raising enough to run the project for 3 years, and after that, we'll sell some more of the token supply. So we have a portion of the tokens set back, and they are released over a 5-year period. So we want to give people that buy the tokens certainty that we're not going to just sell more in the short term.
So Sam, in that respect, what's the percentage what's the circulating supply to be initially in terms of percentage?
So the circulating supply is around 65 to 70%, I believe.
I see. And if we could talk now about the vesting periods or the lockup, because it's something that many people don't simply know about. What is the plan, and how can we be assured that the team itself and the advisors are there for the long haul?
Yeah, well, precisely. The team and the advisors use the lockup period. So the founders, our tokens are released at the same schedule as the project, which is, again, 20% per year over 5 years.
Oh, I see. So that really does ensure that they are there generally alongside yourself to really build out this for at least the 5-year period that you planned. And that certainly does give the initial, let's say, supporter of the utility, a peace of mind that this is essentially something that is a longitudinal project. But if we could also talk now about the hype factor, I do want to address that directly, is that no doubt you've seen these pump and dumps happen, Sam. And I was wondering, is this a concern for you given that you are such a low hard cap?
So what we're using is a proof of interest system on our token sale,
right?
Which is essentially that in order to take part, and we've done the same thing with the funds and institutional purchases as well, which is in order to take part, you have to prove somehow that you're interested in the system. And basically, we're giving out allocations based on how interested and engaged people are with the system.
Right.
We want to build out a community that really cares about the project as much as we do, ideally. So we just reward the people that.
So it's about work first. I've actually heard that. I've heard that quote from another CEO by Fabio Kennison from Next, and he literally said it's all about work first. So that seems to be the ideal here, or the premise is show that you have interest by doing something of value for the project, and then perhaps that's where you have that discussion. So it is interesting that you are doing that. So essentially, Sam, it's about those who really have the best interests of the project, of Arweave, in mind. So they want to foster really what you're about, and that is fundamentally the long-term utility of your project, to actually be implemented in the real world, to have use case, and to eventually spread to become this decentralized web of data storage. So I think it's innovative what you're doing in the way you're approaching this, because essentially you are, right from the outset, you are assessing the applicant very carefully as to their merit of and their worth.
Yeah, I mean, how much we think that they will, well, how much they care about the project, and how much by proxy they might be able to help it spread in the future. Sure. Ultimately, this is a decentralized thing. Although we're at the center of it, pushing it forward, you know, we need miners to get on board with it. We need developers to build on top of it. And eventually, hopefully, we shouldn't be necessary for the thing to run. In fact, you know, it's the goal of all reasonable decentralized projects to make themselves relevant eventually.
Sure. So we just build up the strongest community we can. So it's a value-add approach. Sorry for interrupting, but obviously, you know, right from the outset, it's not necessarily the investor that's at the forefront of the team. It's more, once again, creating this contribution philosophy. You know, how can everyone holistically gather together to build out Arweave? And partners are clearly part of that as well, Sam, and you have some interesting partners on your list. You have UpBest, you have North Block, you have Shelf, and you have Techstars. They are not something that... Sorry. And that's okay. They are something that's not necessarily that, you know, well known in the space. So could you tell us a bit about why you did choose those partners, and what is planned in the head in other partners that you are aiming to forge? Yeah, so we're focused, laser focused, I would even say, on actual usage of the product. We see a lot of people with partnerships that, I'll be blunt, are really just pieces of paper, where they sort of both agree to say that they'll work together in the future, and actually what they mean is they'll agree to swap communities. Right. You know, you're interested in this project, I'm interested in that project. And so we appreciate that, because we don't hear enough of that, Sam, that kind of frankness. Yeah, I mean, I guess it doesn't make you very popular to say it out loud, but yeah, it's true. So we've been focused on people that are actually going to use the project, I don't really want to say product, you know, the network, for something useful. One of my favorite partners that we've made so far, sorry about the others, but this one's just such a cool use case, it's amazing, is what's called the Journal of Raw Data. So in the academic sciences, recently there's been this problem called the reproducibility crisis, which is basically that we've gone back and we've retested a whole bunch of the conclusions that people have come to in important academic papers. And we've followed the protocol that they said that they followed again. And we found that actually the results that they came up with aren't reproducible. And what we really mean by aren't reproducible is it actually looks like the thing that was published and it was peer reviewed wasn't true in the first place, which is a nightmare, because, you know, we're talking about 70% of all of the science that's happened over the last, 50 to 100 years. It's a complete disaster. Right. So finding the cause of this and trying to work out ways to get around it is a major, major imperative right now. I see. Not just in the academic space, but because, that knowledge filters out into the wider world. This reproducibility crisis problem essentially means that about 70% of all of the published science in the last 50 to 100 years might not actually be correct. And this is a major problem, not just in academia, but outside of it, because that knowledge and information that we generate in the academy, if you like, filters out into the wider world and affects the way that society works at a pretty basic level. So what we're doing with the Journal of Raw Data, which is run by a team of professors from Charité, one of the largest teaching hospitals in Europe, is they built an entirely new kind of journal around the system, around the Arweave. I see. Where researchers... Sorry? I see. I actually read about this in your white paper, and it's really exciting that you actually have a real place in the world that's applying this. Yeah, for sure. So what they do is they take the protocol that they're going to follow, and they encrypt it, and they put it onto the Arweave. And then as they collect all of the pieces of data in their study, they encrypt it, and they put it onto the Arweave. And then once they've done their analysis and they publish their report, they publish the decryption key, which allows people to go back and verify all the information that they collected along the way. And this solves one of the
major causes for the reproducibility crisis, as far as we can tell, which is that researchers have this bad habit, really is very, very unethical, of going out to try and test one hypothesis, finding that their data doesn't quite fit, and because they can't get it published, because there's also a sort of very silly thing in academia where we don't publish negative results. So we only published
positive.
We went out to test this thing and we found that it was true. Whereas actually there's an awful lot of valuable information that's lost when we went out to publish this thing and it turned out not to be true.
I mean,
a negative is still a useful data point, personally, I believe. But currently they don't get published. And so what this does is it incentivizes academics to go out and say, okay, well, I'll fiddle with the numbers a bit, or I'll fiddle with what else I said that I was going to go out and test. And then I'll come up with a new kind of report that is, in fact, statistically significant and thus worthy of publishing.
Right.
And so the Journal of Raw Data does is it allows academics to prove that they haven't done this by showing that they've used all of the data that they've collected in their analysis. And just to add another level of cool to it, all of that data is now publicly available for anyone to go back and perform reanalysis on in the future. And not only is it shared because everyone else can access it, but it's also shared across time. So there's no way that data is going to be lost or become unaccessible, which is also a major problem in academia because we don't have centralized repositories of experimental data, or at least they haven't had wide usage or adoption.
And certainly also, Sam, one of the issues is it comes at a cost, usually to the user, when they do want to access, current journals. For example, if you're going to a university, you certainly need to have a membership. What is also interesting is this is happening in the context of a real use case in a hospital. So in that respect, Sam, do you see that this is really just the beginning and that this could be, developed and sort of integrated into a multitude of different industries, not just even in hospitals?
Oh, completely. Absolutely. Yeah, we think that, well, this is maybe a side point, but we think that academic publishing is one of those things that's most ripe for disruption at the moment.
I see.
That's
once again ironic coming from your position as a PhD candidate.
Yeah, I mean, maybe it's the kind of thing where, like, if you experience it, it opens your eyes to the realities, perhaps.
Right.
Yeah. It's a $25 billion industry. And Elsevier has a higher profitability profitability ratio than Apple does. It's really and they haven't changed as an industry since 1850.
Well, let's expand that. Well, let's expand that, Sam, into the wider data storage space, because my understanding is that's in the trillions itself. How big is that industry?
Yeah. As you say, in the trillions. It's very hard to properly quantify.
I see.
Because really, if you look at it, it's just how much, what quantity of hard drives are sold per year, just at a basic level. And then you look at the reselling of that data storage through cloud providers and this kind of thing. And the number becomes, enormous.
And Sam, given that you are trying to do something that is relatively innovative in the way, oh, my apologies, it looks like you've frozen. So, Sam, obviously a $3 trillion, arguably, industry for data storage is something not to balk at. It's something that's very exciting. And as you said, it's very difficult to quantify that. But in that context, you are arguably one that is leading the way. You're certainly doing things that very few, if arguably no other data storage project and company is trying to do. And you have a roadmap that's very clear as well. You have done your alpha, you've done your beta, so they're covered in February and April. And excitingly, you have an MVP, which is extraordinary.
Yeah, I mean, it's not MVP. It's it's a pretty solid implementation of the protocol. It's ready to go on June 8th, which is as we speak.
I see. So June 8th. So June 8th. The big question is, why didn't people know more about you before? I mean, you are literally about to hit, the business of blockchain. June 8th. And then what's to happen from that point forward? So,
I mean, we've been very focused on just shipping product, getting it out the door. It's the most important thing to us. I don't know, the blockchain industry is sometimes quite strange.
Sure.
Going back to the tokenomics thing for a moment as well. I also find it very odd that a lot of projects in the space, they sell 90% of the tokens available in the project before the thing has launched or before they've even built the thing.
Right.
And it gets to the point where some projects are raising 70, 80 million dollars, and they're leaving 5% of the tokens for the project to sell at a later time.
And often they're selling that in the private sale itself as well, Sam. Often they're selling that in the private sale as well, rather than distributing that equitably across all sectors of the sale structure.
Yeah, it's a very peculiar system. Personally, I'm not really a fan, which is why we've done it this way. So we raised a small seed round back nearly a year ago, and then on that, we've built out the entire product, the entire protocol from what at the time was a prototype that ran inside a single computer, and it had simulated nodes that spoke to one another across a simulated network.
Right.
We built that out. We released the first version of the test network back in, I think it was November 11th or something along those lines. And now the test network's been running for about 7 months.
So you've been using the funds from each of these different rounds to really build out the next phase.
Yeah. That's for funding the next phase of the project. We built out the entire system on the seed round funding that we received. I think it's testament to it wasn't a large round by any stretch. It was very small, really, by crypto standards. But you are able to build and ship large protocols and large projects on small amounts of money. It strikes me as insane that a lot of these projects are off raising so much money and not really delivering.
And once again, I genuinely appreciate your frankness. I do try to inject credibility into the space, and no doubt you are doing the same. So it's great to hear that you are a proponent of what does necessitate a great project, not what inflates it, or not what really is quite simply just a quick grab, a very greedy approach perhaps to blockchain, in the sense that it's capitalistic and it's certainly not benefiting all participants.
Well, one of the interesting things about the I don't want to say blockchain space quite, because it's not. It's about DLT. Decentralized incentive networks, right?
Right.
So one of the other projects that I find really interesting at the moment is this thing called Loki. Maybe in a few months you'll see why. But anyway,
I have heard of it.
Yeah.
So Sam, obviously there's some other things we want to talk about right now, and that is your competitors in the space, or perhaps, it may not be competitors, but more participants who are trying to change the game alongside you. But there are two areas of this, and it is the centralized domain and also the decentralized. So we have Amazon via Dropbox. You have mentioned them personally. And then we have participants in the decentralized sort of distributed tech. So what is your position, and what's your viewpoint on those who are trying to do something similar?
Yeah, I mean, my position is essentially that they're not really trying to do something similar.
Okay.
The whole point of the Arweave project is to build permanent information storage for the first time. It's an attempt to essentially make it so that humans can collectively not forget things they don't want to forget.
Sure.
It's not just a kind of hard drive. So you can write data to it, and it's actually reasonably cheap. You can use it in that way if you want. But the thing that the Arweave gives you that literally nothing else can is that it has a system of economic incentives which force the miners to replicate that data ad infinitum.
I see. So obviously implying an infinitude there that continues on, regardless of what any other competitor is doing in this space. So when we talk about things like Filecoin storage, right through to MadeSafe and Zero Chain, quite literally, this is the thing that sets them apart, and you've heard it from the CEO. You've also articulated very clearly about the incentives for the developer, and that is very exciting. There are some things I just wanted to quickly address with you with regard to criticisms. Otherwise, we simply wouldn't have an objective interview. Some of the things I have read and checked into are such things as, a young team, one that doesn't necessarily have completed PhDs. I'll let you just comment on this as more, obviously the time has gone on for the interview. But things like also, the percentage of allocation afforded to the private sale itself. And also the big question of bounties as well, and whether or not they have the potential to inflate social media platforms like Telegram. So what do you say to those kind of criticisms, Sam, given that you are just starting out?
Yeah, from the top that we're young, yeah, it's true. I think it's meant that we've been able to move extremely quickly over the last year from, inception of the idea to delivery of the product. And I also think to some extent maybe there's less risk involved because there's less, you have to trust us less because you can go see the GitHub repository. It's ready to go.
Sure.
We're launching.
So age is no boundary. And clearly with regard to the private... Right. And we've talked about the whole tokenomic structure and you've been very, very frank and we appreciate that. But you did reserve approximately 25%, I understand, for the private sale. Is that correct?
It's about 25%, yeah.
Right. Well, let's say it's approximate.
As part of that, we also have a community sale, what we call the community sale part 1, which accounted for a large portion of that private sale. And that went to people that have been watching the project since the start of it back a year ago.
So you're comfortable, obviously, with that plan and that allocation. Okay.
Yeah. I think the people that have been with us for a long time have all got in on the private sale round.
Right. And what about the bounty with regard to, obviously, Telegram numbers? I mean, it's one of the big sales pitches we see is how much the social media influences the success or implies the success of the overall project. So what would you say to bounty programs having an effect on that?
I think, two things for a start. We had a Telegram referral program for a while. But it was for about 3 days. Because it was sort of effective, but not as effective in the way that we wanted it to be as possible.
Right.
And actually, that sort of lit the fire on the finding of Arweave. And since then, we've been growing at a rate of 1,000 or 2,000 users per day.
I see.
Without really spending any money on marketing at all, or having any kind of bounty system. Just people finding the project naturally.
Right. Well, you've clearly had very organic growth, Sam.
Yeah, certainly. And actually, I think one of the things I like least about the industry is this focus on social media as an indicator for the livelihood, the goodness of a project. It really doesn't work very well. So, for example, in our system, we're very, very focused on bringing developers into the ecosystem. Because if you bring a good developer, bringing an actual application that people outside the crypto space want to use, then for that one developer, you get 2,000, 10,000, 100,000 active users of the system. So that's really what we've been focusing on. And indeed, with the proof of interest system, this is, the top of the list is, can you develop applications for the system? Are you interested in doing that?
Absolutely.
And as you said, with the semi-autonomous fund, that's also what we're trying to incentivize too. So, I think this is something that in the longer term, the industry will move away from.
Absolutely. And Sam, it's really exciting that you are saying this because essentially the message I'm getting from you is that you are tech-driven, you are quality-driven, and you are longitudinally driven for something that really builds out excellence for data storage, for real use case. And you're making the point very clearly that perhaps we are too quick to be influenced by essentially the social media space when in fact it should be the tech that talks.
Yeah, I think, for some projects, maybe for something that was just a straight currency, then it makes sense, right? Because you need people to adopt it, and it's a reasonable question to say, all right, how many people are in their Telegram channel? Maybe that shows you a number of people that might be willing to use the currency to transact.
Sure.
That's sensible. But for something that's a utility, that's mainly focused on developers, or other projects that might be focused on one small industry that is, say, one specific industry that has a high worth. They might be focused on that zone. So then it might be more appropriate to look at the partners they have in that space.
Right.
But in our case, we're just looking for developers.
And clearly this couples well with traditional models of reporting, in that if in fact you are a great use case and you have a real utility, there's no question that will become brought to light. It will be elicited by excellent reporting as you develop. So hopefully that's what I've done for you today, and simply the objective is to bring that and what you're doing. But Sam, it's obviously been a privilege talking to you as the CEO and co-founder of Arweave. You are developing Blockweave, which is a very exciting blockchain-like architecture. Is there anything you'd like to say, Sam, to finish off to not only the audience, but to all those who perhaps don't know anything about Arweave?
No, come have a look at the project. It's arweave.org. and come talk to us on Telegram. We'd love to speak to you. And it's been great speaking to you today, Brad. It's been fun.
Likewise, I've learned a great deal about Arweave. It is no doubt a very exciting decentralized data storage solution. It's doing things that simply haven't been done on the blockchain, or more importantly on the distributed ledger technology space to date. And we wish you all the very best, Sam Williams. You are leading something very exciting with your team, and we look forward to also following you along, not just today or tomorrow, but for decades beyond, as you become something that will revolutionize arguably the decentralized web.
Thanks. Looking forward to it. Great speaking to you.
You likewise. Thank you very much.